Welcome to my Java video series. Today we'll talk about how to create objects, how to create a class, and different variants related to the class and objects. So let's begin from a small discussion on the class. So we have already talked about we have a lot of discussion about the class in previous series. So a class is like this, which is divided into two parts, and the first part will be your data member. We also call it properties, and the second part is your actions, and you can also call it your methods or functions. In terms of C we call it function, or in terms of Java we call it method. Okay, so a class contains two things: data member and member functions. You can identify the data member with the help of adjectives. If you could identify adjectives, they will be treated as your data members. So adjectives are describing your object in the terms of data, and methods you can provide here. So they are verb, so verbs will represent your data members. So this is how you can see your class, or objects will looks like the class. And when you take the example here, it is very easy to relate with the real world examples so that you can quickly imagine your class. So here I'm going to talk about a real world example. I take this course through the dog animal approach so that you can quickly understand and implement the object oriented philosophy in a right way. So let me assume a class here, a dog. So this dog class contains different adjectives, so I can say name of the dog, age of the dog, color of the dog, weight of the dog, and I can identify different verb for the dog. So dog is an animal who can eat, who can run, who can bark, like this. So you can have some other methods here related to the dog, and you can have different adjectives for the dog. So this is how you can see a simple example for the class. So class contains two things: data member and member functions, and data members can be identified through the adjectives, and actions can be identified through the verb. Now let's begin with the code. So I can start from any editor, so I will take few examples from the command line approach. So let's begin with the notepad. I'm using here notepad++. You can go with any other editor also. So let's create a class here. So I'm going to create a class here, class, and name your class dog. Now as we talked that a class contains two things: data member and member function, add here properties or data members. So integer age, I'm going to take age of the dog and name of the dog. And now I'm going to add a method here, add one action here. So add one action here as we discussed recently. So I'm going to add here one action. So dog is an animal who can eat. System.out.println. So let me print a small message here. So this is dog eating, and I would like to print the data present in the object using this simple concat approach. So this is age. So we'll talk more about how to set data into the object and how to access the data from the object in coming series, but this is a very simple example on the class object. Now so here the class is end. we should not write here semicolon just like C++, so just remove this. Your class is end. In general practices, we must create one file, one class. One file must contain one class. These are some good practices, but to start with, I'm going to create a main class in the same file. So this is my test dog, this is my class, and this is my main class basically, because I'm going to provide a main method here. So this is main class. Now provide a main method here. So this is how you can add. Now it's time to create object for the class and access the data member and call the method. Now before that, let me save this program to my folder I'm working on. This is E drive I'm working, and save this program here. So this is my class. Okay, testdog.java. Just a moment, let me take you through this folder and clean up the directory here. Go to E drive where I saved my program. This is your folder. I'm going to create a folder here, old, and shift all my old programs there. So where is my recent class? I worked on the test dog, keep that here, and rest of the programs I'm going to move in old directory. Okay, now this is the class I recently created, test dog, and let me complete this code here. Now create the reference here. I'm not creating object here, so d1 is a reference, so this is reference only, this is not an object, so it's a reference only, not an object. So this is how you can create a reference. Now it's time to create object here. Now I'm going to create the object through this new keyword. So this statement will create object, and that object will be assigned to the reference d1. So this is how you can create the object. Now let me draw this scenario. Now when that line is executed, you will see here one object like this. One object will be created here with the data members. The object will be divided into two parts just like your class. So it will have name and age. So name will be by default. If you do not initialize the name, this will be null, because string is a class and the value for the default value for any object type or class type will be null, and age is a int and default value for integer will be 0. So this is how you can see the default allocation for values, and you will see one method here. This is second part is a method. Now this is your dog object. I can call it a dog object, and it will be located at this hash code 111. So 111 is a hash code of the object. Now this is created from this right hand side, and now it's time to understand the assignment operators. So this assignment operator will assign the value from right hand side to left hand side. So what will be assigned into d1? So d1 will hold here 111. Okay, once you have got the address in reference, you can point to the object here. Right, now let me call a method here. So call a method here d1 dot so this is how you can call a method from the object. Now save this program and check the output here. So go to the command line here, go to the terminal command prompt and move inside the D drive. Sorry, I'm working on E drive, and now move into work directory. You can check the program I created recently. So this is testdog.java I created. Now compile this. So this is how you can compile. So when you compile your program, you will get here .class file generated for you. So this is my directory work, and look at this. I declared two classes in my program, and there will be different dot class file created on behalf of the each class declarations. So I declared two classes, and you can see here two different bytecode files. So this is internal work done by your compiler. So for every class declaration there will be a new dot class file created for the compiler. So no matter how many classes you declared in one file, but internally it will be divided into different dot class files for each class declaration. So now this is ready. It's time to run this program. Now call this main class here, test dog, and this is how you can see the dog eating. And look at the default value, null and 0. So null and 0 is a value, as I recently described in this diagram. Null is a default value for any object type, and age is your 0. So this is age is an integer value, and default value for int will be 0. So this is how you can see. And now let me talk about the initialization of properties. So I can pass data, I can input some data in the object using this simple technique, d1 dot, I can directly initialize here d1 dot age equals to, I can pass here age of the dog is 10 years. So what will happen here? So when you create the object here and initialize values, this property, this 0 will be overridden, and the new value will be 10 years. Look at this. Right, now again try this, run this program. You can see here, recompile this and run this. You can see here value, this is 10, and this is the value I initialized in the object. Similarly, I can initialize here name of the dog. So d1 dot name, and let me call the name of the dog is Tommy. So this is a dog. So what will happen in the object graph? This diagram is my object graph, and this value will be changed to Tommy. So now it is not null, and this will be your Tommy. So this is how you could see. Now try this, and again you can check the values here, recompile the program and run the program. So you will see here values, dog eating, Tommy and 10. So this is how you can initialize the values in object and access through a method. So now you can access the member from this technique, d1.eat. When you write here d1.eat, you can call this method. This method will be called. So when you call here d1.name, you will access the data member of the object. So d1.name will be this first property, and when a method is running, it will access the data from its personal object. So when you call a method, this method will access the data from its personal object. This is how you could say. So each method will access the data from its personal context. Now I'm going to create here one more object. I'm going to create here another object. So here I'm going to create dog d2, and I can directly declare the reference and create the object in single line. So this is how you can see. In previous case, I declared the reference separately and I created the object here. This is create object, but in this case both things you can combine. So here you can declare the reference, and here you can create the object. Now d2 dot, I'm going to call a method here, eat. It's very simple. Again you can run this test dog, and yes, look at this, the another object has same scenario. So this is another object, and this object has default values just like the previous case. So let me create one more object here. So this is my new object, and it has data like the previous one. So this is my another object, and name will be null here, just like the previous case. Name will be null, and age will be 0. Okay, and it has eat method here, and this is referred by d2. So this is your second object d2 pointing to this object, right? So this is your another dog object. This is another dog object located at different hash code. 222 is a hash code for this object. Now go to the program here. I created the object here and I'm calling a method. Run this. So you can recompile the program and re-execute this. So this is Tommy 10. This is your first object and this is your second object with the default values. Now I can initialize the data here for the second object. This is d2 dot, I can call here, I can initialize the age. Suppose second dog, age for second dog is 5 years. So what will happen in your diagram? So modify here object graph. The 0 will be now 5, and let me change here d2 dot name. So d2 dot name will be, suppose I call it Siju. This is a new dog, and complete this. Go to the diagram and this name will be changed now to Siju. So this is how you can change the data here. So first object contains different value, second object contains different value. Every object created in a memory will have its own copy of data. So the first object has different data and second object has different data. When you modify the data in first object, it will not reflect to the second object. So this is the behavior of instance variable. This is the behavior of properties. So every property contains their own data copy inside the object. So let me run this quickly. Now run this. Look at the data here. This is your first object Tommy 10 and Siju 5. So this is a method I'm calling from the first object, and this is a method we called in second object. So both object has its own data copy. It will not share the data. So this is the behavior of the property. Now let me write a small example here to understand the behavior of references. So I'm going to use another reference here. This is d3 and I'm going to assign from d2. So this statement is called assign reference. This is I'm assigning the reference. So what will happen graphically, you can see the internal behavior of this. One new reference is created here. This is d3 and this is pointing to the same object. You have assigned the value from d2, so you have got a new reference, but this is not a new object. This is how you can see. So when you call a method like this, d2 dot eat and d3 dot eat, both will be executed inside same object. Both are pointing to the same object. So you can call this method from either d3 or d2. Similarly, these members can be accessed and shared by same reference. So this is d2 dot age. When you call d2 dot age or d3 dot age, you can access the common data member through this technique. So this is how you could see. So you are accessing common data member from this one. So when a reference is assigned, d2 and d3 both are pointing to the same object. In fact, if you modify the data from d2, it will reflect to d3. So this is just like you have two remote controllers pointing to the same object. Two remote controllers pointing to the same projector. So here projector is an object which is accessible from two different remote controllers. So this is a behavior supported in object. So here how many objects are created? Only two objects are created, but three references you could see. So we have two objects and three references. So d1, d2, d3 are references, and this is the object, this is the object. So now let me show you the internals. So this is how we created here D1, D2 and D3. Now let me talk about their internal hash code. I can print here. You can check the objects here. So this is how you can see D1. I'm going to print D1 dot hash code C capital. It's following camel case convention. This is D1, D2 and D3. Just a moment. This is D1, D2, D3. Now look at the output here. Check this. Recompile the program and try this. So this is how you can see. So when you create the object, look at this. This is your this is your D1, this is your D2. One more thing I forget here. Just a minute. Go back to the program, and I forget to call a method on D3. So just do that D3. Okay, fine. Come back to the program and talk about D1, D2, D3 first. Then we'll see the hash code. So look at this. This is your D1, this is your D2, great, and this is your D3. Look at this. D3 has same value as D2, so the values are same in D3 and D2. So this is CG5, CG5. Now look at the address also. This is your D1, this is your D2 and this is your D3. Look at the references here. This is 700, 700. So basically D2 and D3 both are pointing to the same object. That's why you could see here common hash code. So this is the proof that only two objects are created, and this second object is shared by D2 and D3. So this is how you can see the behavior of objects. So thank you very much for now. In next program we'll talk more about the objects, and we'll understand how to initialize data in different way and how to access the data from the objects. So thank you very much for this series, for this session.